Hello, everyone. This is Dan here from Prompt Up, and welcome back to our YouTube channel. It is Friday, April 5th, and we will be talking about prompt engineering today. Specifically, we'll be talking about how different prompt engineering strategies translate or don't translate across different models and how they each have their own kind of specific approaches. So, a question that came up when I was talking to a team recently was, how sensitive are the models to different types of kind of best practices or phrases or things that you see picked up on the internet as like good prompt engineering phrases to use, such as something like chain of thought, reasoning, which is most commonly thought of or used as with this kind of directive that says think step by step. And generally, what chain of thought attempts to do is to help the model reason more. And this, think step by step is just one popular way to make it happen. And so this is like generally, I would say, one of the more accepted kind of best practices when it comes to getting responses from LLMs. But there's in the Palm 2 technical report, you'll find that actually the chain of thought reasoning led to degraded outputs, led to worse outputs. So even something that is generally pretty widely accepted, I would say, doesn't hold for even some of Google's best models. And so it makes you think about, okay, what other best practices that we see kind of generally appear here and there can actually be translated to different models, or do they only relate to that model that the paper or research is about? And so we'll be looking at a couple papers to kind of dive into this. This first one is from VMware. It just came out in the last month, and it's a really great paper. They essentially ran two experiments. This first experiment was what they wanted to do was test a bunch of different positive thinking type phrases. So in total, they had 60 prompt system message variants with 5 openers, 3 task descriptions, and 4 closers. So 5 times 3 times 4 equals 60. So those are all the different permutations that they set up. And you can see they basically just wanted to test, hey, how do these kind of phrases work? So the baseline that they're comparing to is just the regular prompt, and then they add the system message with these various types. So here are a couple of examples. So when they use an opener, and then when they don't use a description or a closer, and then, so on and so forth. And so they tested this on a mathematical data set, GSM-8K. It's a very popular one. And they scored it using exact match because, every math question has a known answer. And they tested it across a couple of models here. So Mistral to Llama models varying in size. And so here's generally what the results looked like. Let me just pull up my notes here, but we'll start with looking at Mistral. Two things I would say kind of we want to look at is baseline versus the mean, and then also the standard deviation. And we could see generally the mean and the baseline are they're pretty close, right? There's not that huge difference. And the standard deviation is really low as well. This is when you're not using chain of thought. So they did chain of thought for a set and then not chain of thought for a set. So when using chain of thought, the model exhibited pretty strong improvement in output correctness above the baseline. So you can see here, this is almost like a 50% increase, some amount, much larger delta compared to without. And so in this case, you could say, okay, when using chain of thought, these positive thinking directives or phrases seem to have a positive output on the results and correctness related to at least these mathematical tasks. Coming down to Llama, deviation decreases without chain of thought, except for this first one. Generally, it decreases as the number of questions increase. So that's what's being varied here. And generally what that translates to is that the effect of these positive thinking phrases are at least much less clear compared to the examples above with Mistral. You can see the baseline versus mean are very, very close here. We don't have these kind of big jumps. And then for 70B, looks pretty similar. Decrease in standard deviation without chain of thought thinking here. And positive thinking prompts actually have a negative impact, under making them underperform the baseline. So if we look here, it's even. Here it's much worse. Here it is again worse, and then even with chain of thought thinking, it still underperforms, and overperforms finally on the largest data set. But overall, 7 out of 8, 6 out of 8 times, it was these additional positive thinking phrases underperformed. And so across the board, I think 2 major interesting takeaways. The use of chain of thought reasoning tends to introduce greater variability in the standard deviations. It's likely because the model goes down these more complex reasoning paths, because that's what chain of thought is what it's supposed to elicit. But aside from that, the biggest trend is that there really is no trend. There's no consistent effect of positive thinking directives across all models. We could see in Mistral, it made a positive difference. In Llama 13B, so-so, but then the larger version of model at 70B, it actually was detrimental. And so this highlights the importance that these phrases and these effects of them, either the chain of thought or the positive thinking phrases, are pretty specific to the models in this case. And again, looking back at these examples, these are actually the top performing ones, increasing with the scores on the side here for Mistral specifically. And so, because there was no general trend for these human-tuned prompts, the researchers want to set up a experiment where they had the LLMs optimize the prompts themselves and see how that performed. And in general, most of the LLM-optimized prompts either outperformed or were on par with those human-written ones. We've seen, a lot of research about this in terms of, how effective LLMs can be at optimizing the prompts. And generally, our takeaway is that a good mix of humans and LLMs is a good way to go for a number of reasons. You want to be able to kind of reproduce or know how you got to a final answer rather than just having an LLM basically get you all the way there is kind of the main reason. And this is a really good example of that. This was the top prompt for Llama 70B, and you can see it kind of takes on this Star Trek type theme, where it's, Commander, we need to do this, Captain's log, star date, yada, yada, yada. It's so divergent from anything I would have ever written or what I think anyone would have even thought to write, which I think was really important to highlight. And then even for the smaller model, you can see how different it looks. Of course, we're not in Star Trek land anymore. And you can see this one's more just kind of laying everything out. Mistral's is pretty straightforward and to the point. So these are the prompts that the LLMs created to continually optimize to get the best outputs. So this is after a lot of repetition. And so again, if you look back at those prompts, you could see they're very different. And it again points to the kind of intricacies of each model, and that you can't kind of just say one size fits all. And then one other paper we'll take a very quick look at, large language models as optimizer from Google DeepMind. We put a rundown about this, which I'll link below. Generally, it was a kind of system for LLMs to optimize the prompts that they were writing using this big meta prompt here, which we'll look at. And these orange pieces of text are the instructions. These are examples in blue, inputs and outputs, and then the orange text is the instructions. And so the instruction here is write your new text that is different from the old one, write the text in square brackets, et cetera, et cetera. And what they wanted to do was basically have the LLM optimize those instructions based on the outputs that came. And so if we look at it, there was a top instruction for a bunch of different models. And coming here, we can see for Palm 2, it was take a deep breath and work on this prompt step by step, kind of similar to typical chain of thought reasoning. But if you look at GPT-4 here, it's considerably longer. It just takes on a much different structure and tone. And again, points to just how different these kind of top instructions were. when you're looking at different model types. And so overall, when you are, using different models, or even if you're using the same model over and over and over again, these things do change and update. It's really important to kind of thoroughly test them and try to find as much of the best practices that relate to that specific model as you can, and be open to explore kind of these different things that are working across different models. So that is it for today. Again, we'll have a bunch of links below for resources to go deeper on this, links to all the papers. And yeah, one size does not fit all.